Hello everybody, and thank you so much for joining Sarang and myself. We've got some great content. We've got a presentation which will last for about 25 minutes, including a demonstration. I'm joined by Sarang Tripathi, and I will introduce Sarang in a moment. We're going to focus on some key ingredients for any machine learning operations in this session. Our focus really is on the data side. We're not going to present yet another machine learning tool or framework. So I'll move forward and just introduce ourselves. My name is Suki Sandhar. I'm the VP of International Pre-Sales, and as I said, my partner in crime is Sarang Tripathi. Sarang and I have worked together for many, many years. I love working with Sarang. He's one of the brightest, greatest things we have on our team. I always know I'm with in safe hands with Sarang running some of the demonstrations and presentations with me. Some of the topics which we'll cover today, as I said, our focus is more on the data demands of machine learning, and I'm sure many people will talk about how important data is to the training of a model, to the execution of a model, to the testing of a model. The accuracy of a model depends clearly on the amount of data and the variedness of the data that you have. I will then talk about some examples, some use cases to validate some of what we've talked about, and then Sarang's going to jump in and run a really good demonstration. The demonstration we're going to execute is going to come in two parts. One running on a Spark framework with SingleStore running on it, and one without SingleStore running on it. We will run a model training execution, and then we'll a testing execution, and then we can test with and without SingleStore. And after that, we'll wrap up and open up for some questions. I'm always on the lookout for new and latest uses of machine learning. It's unfortunate but very topical, I guess. Despite the risks and limitations of AI, it's making a big impact on our lives, on our day-to-day lives across many different industries. Here's an example that I picked out, something on the BBC website, using algorithms to spot a COVID cough, using cough samples. This has been run by any number of people, but two of the organisations who've been working on this independently of each other have recorded different kinds of results. I'm always interested in jumping into the detail of some of the machine learning. How much data has been used? What is the accuracy of that data? So the interesting thing here was, by May of this year, the data set that was used was something like 459 cough samples, and these are sound samples that are submitted by the public. They are obviously digitalized, they're sampled, all that data is put together. The first organization to publish some results around this, and the accuracy of their model was around 80% accuracy. MIT later on collected about 70,000 samples. Each of these samples have different data in them. They tested and tuned and trained the machine learning algorithm, and they proposed to have something like, they have a 98% success rate in recognizing a COVID cough. It just kind of shows how proliferated machine learning has got, but it also shows something which is the topic of our conversation, is how important data is to all machine learning testing and execution. Of course, COVID isn't the only area of our lives that has been impacted by machine learning. I guess besides the risks, there are many different industries that are using AI and machine learning in their day-to-day operations. Some great examples in retail, transport, and logistics, and I've worked on some of these myself in shaping the operations, what happens to logistics and transport, container ships as they come into port, the predictions on what to buy next or what to show next to customers, adding value to the customer experience through machine learning. I'm going to move on now to dip into the bit more of the detail of the data. It's interesting. Machine learning workloads and some of the challenges around the end-to-end life cycle. If we look at the end-to-end life cycle, it includes not just training a model, testing a model, but also the execution of a model itself. And if you have a look at the different tools, different databases that are available for data scientists to use, it really kind of splits down into these two kind of groups that I'm sharing with you on the diagram. But they use different kinds of data, and this is quite key to what we're talking about today. The initial training of an algorithm, the testing of an algorithm, happens with a large data set, as big as you can get it, I guess. That's typically a data set that you're slicing and dicing against. Obviously, the bigger the data set, the longer it takes some of these tools and technologies and capabilities to execute against, and that is an area of focus for us. But then there is the other side, the kind of real-time execution side, which is the real-time OLTP side. These are applications which are scoring in real time, which need data to be passed to it. There has to be some kind of execution, some kind of bringing together of historical data, real-time data. And if you have a look at machine learning and some of the operational analytics capabilities and use cases that SingleStore really focused on, is this kind of mixed load, this mixed workload of data, of OLTP data and also OLAP data, creating what we refer to, and people like Gartner refer to, as a HTAP database, which is what MemSQL is, what SingleStore is. Let me just share with you the kind of complexity within the machine learning life cycle, and you can see in these kind of broad 10 steps the definition of the use case, data exploration, you selecting the algorithm, creating pipelines, building the model itself, moving on to kind of presenting the results, you plan for deployment, you're operationalizing the model, and then monitor the model. And clearly there is a circular dependency on this to make it the model as accurate and allow that model to be tuned to any changes that are going on in your operations. So we know that many people would iterate around this cycle using any type of tool and capability. Today we're going to talk about, as we're talking about, Spark and SingleStore running underneath. I'll come back to that diagram, but some of the key challenges that are addressed by the SingleStore distributed relational SQL database are focused around these kind of three key areas. We're looking at modernizing the data infrastructure. There is a new set of tools. There is a new set of the way people want to execute machine learning, the life cycle of a machine learning design. That goes with a new set of tools. These tools have to be scalable. They want them to be performant. They don't want to be waiting days of execution of the models when you're training. And lots of people are now starting to move and look for a path to the cloud. So it's an area of focus certainly for SingleStore, being being a hybrid database, we are agnostic to any of the cloud infrastructure tooling that's out there. We can start on-prem. We can then move to a self-managed mechanism. We can also then go to a managed service using SingleStore managed service itself. If we have a look at some of the model design and the interactive part of exploration, there is this understanding that there is interactive SQL from big sources, new sources of data coming in from HDFS, S3, Kafka. SingleStore does a great job of mapping to some of the parallel execution and ingestion, mirroring some of the design for these input sources, especially like Kafka, even flat files. SingleStore does a great job of mapping that parallel execution because the deployment allows you to ingest these files in parallel. And last but not least, kind of operationalizing these models using real-time and historic data, which allows you to execute in real time in milliseconds using standard SQL executed on top of SingleStore. Before we get to the demonstration, I've kind of gone through a lot. I've talked about some of the mixed workloads of data, some of the areas of focus for SingleStore. I wanted to share with you where we've done this already. This is a great case study for us, one of the major US banks. This is all around machine learning for picking up fraudulent transactions. When you do that during the authorization cycle, there is a window of time that you've got to execute to provide that authorization, but also to execute the fraudulent machine learning algorithm to score that transaction. If you take the end-to-end being the window of time being 1 second to allow you to execute the authorization transaction, clearly the scoring has to happen in parallel to that, and we can't have all that single second. We get a subset of that using SingleStore as the underlining data platform. We were executing data, passing data into the algorithm, scoring that algorithm within 50 milliseconds, and that is a great time window because we're not taking up the full kind of second and allowing the rest of the application to execute as well. So that's a great example of how using SingleStore to underpin the real-time kind of operational execution of machine learning really is accelerated by using our technology to underpin the execution. If we have a look at some of the detail around that, the next level of detail down, you can see the architecture of how that's working. The execution request comes in, the authorization request comes in to the OLTP application. The OLTP app then passes out a query set of data. It queries SingleStore. SingleStore in real time executes the SQL. It executes against the historical data and the real-time data that's been passed in. The data is analyzed and then passed back into the application, and then the request is scored and passed out, and a result is sent back. So it gives you some idea of how and where SingleStore sits in terms of the end-to-end operational execution of machine learning. Looking at the next level of detail around SingleStore, which is the database of now, there's really kind of three key areas, key differentiators for us, which allow us to add value to the machine learning life cycle. The first is we are a scalable, highly distributed relational SQL database. We are ANSI SQL compliant. So you'll see when we execute the demonstration, you can pass out standard SQL from any of your machine learning tool sets and execute that on top of single sources database. We are built for converged data. This is one of the great aspects of the design of SingleStore. We mix row store, which is primarily running in memory, and column store, which is disk based. So we're bringing together those kind of two worlds, allowing you to high speed ingest into memory first, and then slicing and dicing that data on disk, which typically requires much more data. We then kind of do provide optimization for real-time execution. I talked a bit about that, but there is the ability to map to some of the new style of architectures that allow you to parallelize the ingestion of data and the execution of queries and results. We also have some unique patented designs which allow us not to lock out any of the tables for execution, allow people to read this data in mass concurrency in high performance use cases. I'm going to move on next to talk a bit more about the demonstration that Sarang's going to execute. We're going to use Spark to do this. The architecture is quite simple. Spark and SingleStore kind of come together quite easily. This is leveraging existing models already put in place with a Spark connector, and we'll show how kind of easy that is. Apache Spark can push down models built in Python, Scala, Java, and leverage the speed, the execution capability, the new architecture that SingleStore's put in place on the database side. We will share with you some results. As I said, we're going to have two kind of parallel executions for the demonstration, but typically we do see kind of 20x performance improvements with execution, and we are compressing large amounts of data which we store in the column store database. So with that, I'm going to just kind of explain where in the life cycle of machine learning we fit in, and the combination of a Spark framework and SingleStore would help and execute within this kind of life cycle. So this is the same kind of diagram I shared earlier. I've outlined the places with these kind of purple outlines where SingleStore as a database is and can be used, and is used to add value in terms of speed of execution, high performance at lower cost of execution. And it's in really kind of two parts: the use of the SingleStore database within this kind of life cycle. It's upfront when you're exploring the data. You're testing the models, you're training those models. So that's the kind of upfront execution that we are associated with, and then there's the real-time kind of execution on the operational side. And with that, I'll just explain the demonstration, and then I'll hand over to Sarang to kind of share this with you. So we're going to start with using the SingleStore Studio. I'm going to show you how we can set that up, the amount of data that we've got in there. We're going to run an experiment. We're going to use Jupyter Notebook to execute this on. So we have kind of Spark and SingleStore running on the same notebook. We're going to build a model using a Spark framework. We're going to use an embedded database, and then we're going to push the standard SQL down to SingleStore and execute that same machine learning algorithm for training and testing purposes. And with that, I'm going to hand over to Sarang. Sarang, you've been pretty quiet. Now's the time to execute the demo. Thank you very much.
Now I'm going to run my query on the memSQL table. You'll see the table is tpch.lineItem. I select my columns and how much data I want. Then I'll select my feature columns, which essentially means what columns I'm going to use to predict my outcome. I'll then split my data with train and test sets to both train my model as well as validate. So the next step is to go ahead and actually train this model. But before we do that, let's jump into MemSQL Studio and do a bit of resource usage profiling to see what MemSQL is actually doing during this process. Welcome back. So it looks like the model took a little under 2 minutes to train. That's not bad. Let's see what happened in MemSQL Studio. It looks like MemSQL simply has a select star from the table that took up 60% of my CPU almost. That doesn't seem very efficient. Let's see how we can make that faster. But first, let's go ahead and test this model and validate that it's going to work for us. Welcome back. It looks like the model test portion took another 1 minute and 40 seconds. So let's go ahead and assemble our final data set that's going to put the predicted values together. We can also validate that we have a good model here. 0.86 R squared seems sufficient for now. Now, what we'll do is go ahead and look at our final data set. Welcome back. Now we have a full data set with the predictions. So this is the predicted column, in addition to the original columns that we used to make that prediction. Now this is great. We have a model that it took a few minutes to build. Let's see how we can do it faster. Now I have an identical Jupyter notebook, with the exception that one line is different. Here I have disable pushdown equal to false, which means all Spark data frame operations within this Jupyter notebook will get translated into SQL and executed with high performance and excellent concurrency into the database. Let's see how it works. I'm going to go ahead and instantiate the Spark session again. I will make that same database connection, but note that disable pushdown is false. Same query. Same features. Same method of splitting my training and testing sets. And now we're back to training the model. Before we train the model, let's yet again go to MemSQL Studio and start profiling the resource usage. Let's go ahead and start training the model. Welcome back. Wow. The model took only 29 seconds to train this time.
Thank you for that, Sarang. Great demonstration. It's always good and right, certainly for pre-sales people, to be able to kind of not just kind of share slides, but in a session like this, show something running, something executing. Thank you, Sarang, for that. So a quick summary of the demonstration. You saw two kind of executions of model training and model testing. We showed how you can use the integration between Spark and SingleStore by using pushdown of the SQL, either false, so that it's not pushed down and you're executing locally using local databases, and then true, where the SQL was pushed down to train and test that model. We're built for high performance at lower cost. We'd love for you to go away as a call to action to go and try the SingleStore database for your machine learning lifecycle. You can do this today. You can try this for free. We have two kind of ways in which you can do it. We have a SingleStore managed service where you can kind of go on, register yourself and use and execute the SingleStore capability as a managed service. So please go ahead and do this. And with that, we've still got some time. I will open up for questions. Thank you very much, everybody, for listening.